Welcome to the SNIA Experts on Data podcast. Each episode highlights key technologies related to data.
Welcome, everybody, to the SNIA Experts on Data podcast. My name is Eric Wright. I'm the co-founder of GTM Delta and the host of the SNIA Experts on Data podcast. Very excited to be able to bring an amazing team of folks together here. We've really looked at SNIA in some of the previous chats about some of the specific topic areas and innovation areas and research that's going on. This is a real great chance for us to go back and what's the core of SNIA? And we thought about what are the different areas in which we look at SNIA in how data and being data-centric in a storage mindset and storage-centric in a data mindset. When we look at how data works in the SNIA context, if you go to the SNIA website, you'll see lots of great updated information on the different practice areas. Some will line up with some of the technical working groups, and we'll talk a lot about that today. So I'm not going to pre-podcast the podcast because I got the greatest folks on the mic with me. And with that, I'm going to do a quick ask of some introductions along the way. So if we want to get started, just give a quick intro about yourself for folks that are new to you. Bill, if you want to kick us off.
Hi, great. Thank you, Eric. And I'm Bill Martin. I am co-chair of the SNIA Technical Council, and I work for Samsung as my day job, and am kind of facilitating this overall podcast with these experts in these various areas.
Excellent. And Craig as well?
Hi, I'm Craig Carlson. I'm on the SNIA Technical Council, and my day job is I work for AMD. I do storage and networking. I've been involved in storage and networking standards for over 20 years, including Fibre Channel, NVMe, and many others.
All right, Team FC. I'm old school. I love that stuff. Fred, you're next up.
Thank you, Eric. My name is Fred Knight. I work for Kioxia, and I'm part of the SNIA Technical Council. I've been in that role for a number of years and have, I hate to admit it, 30 to 40 years of experience in the industry, and going back to some of the early Fibre Channel up through the latest and greatest NVMe technologies.
We all have this amazing thing where we basically cut off part of our leg and count the rings, and there's a lot of time and technology amongst those years, so I love it. But looking to the youngest of the crew, and last but certainly not least, Anthony, you want to do a quick intro for the folks?
Sure, and everyone's making me feel so young right now, so this is great. My name's Anthony Constantine. I'm an engineer at Intel, and what I do for SNIA is I'm on the technical council, as well as I'm the co-chair of the SFF technical affiliate.
Excellent. Well, thank you, everybody. And today we're going to talk about transport. Transport is an interesting section of the overall SNIA practice areas. And I think the best way to lead it off, let's talk about what does it mean when we talk about SNIA being experts on transported data. Bill, let's have you kick us off.
So great. Thanks, Eric. So what is it that SNIA is experts on transports? What does it really mean? So what it means is we work together with a lot of different organizations within the industry to develop transport standards. We try to bring some of that together. We try to provide education. Part of what SNIA has, we have a SNIA forum called STAY, or the SCSI Trade Association, that is now part of SNIA. They do all of the what does the market need for SCSI? And they're looking forward to SCSI. They're arranging plug tests. We'll get into a lot of that a little more later in the podcast. And then we also have, as Anthony mentioned, he is co-chair of the SFF Technology Affiliate, where we develop standards for storage devices in terms of connectors and form factors. And then finally, we have a large number of alliance partners. Among those alliance partners in the area of transporting data are FCIA, NVMe, CXL, as well as having liaison arrangements with all of the Insights T committees, which have recently been renamed by Insights to now be the ATA committee, the SCSI committee, and the Fibre Channel committee, although I'm not getting the Insights names right for those.
Well, I think it's a really great kickoff for us too, Bill, because if we look at how SNIA in general works, it really is, there's what work we do internally across different sections of SNIA practice areas, and then the alliance partners, and we're seeing stuff like CXL and some of the external partnerships that are coming in. So that's one of the things I've really enjoyed about SNIA's approach, is that not just defining standards internally, but looking to the industry and helping to give guidance. And then we're seeing more and more partnership come up. And when we talk about transports of the day, let's start by going through. And like I said, Team FC, I'm going to go old school. Craig, Fred, let's talk about what are some of the important transports that are in play today. And let's talk about Fibre Channel and SAS and where where it is and even potentially where it's going.
Well, Fibre Channel probably would be considered one of the original and the oldest SAN, storage area network technology. The Fibre Channel specification goes back 30 years. And I was part of it for a good portion of that, probably longer than I want to admit. I chaired the protocol committee and a lot of the other work groups. The thing about Fibre Channel is that it has stuck around, despite the fact that people every few years declare it dead. It's still in there and still being deployed in enterprise data centers. It's still a very important technology for a lot of the enterprise customers are using Fibre Channel, basically because it's been around for a long time. It's reliable, stable, fast, and they trust it. Right.
We should do a dedicated one just called "Fibre Channel is dead, long live Fibre Channel," right?
Exactly.
Now on the SAS side, Fred, what's happening and what's happened, and where do we see SAS being really prevalent today?
Well, SAS came about from the original parallel SCSI days as part of a smaller, more local kind of network with SAS switches and such. So they're sort of a younger brother of the Fibre Channel area, and using a serial protocol rather than the parallel technology. But it has still gone through a number of speed bumps, getting faster, adding new capabilities, and improving the performance, still offering all of the full features that SCSI offers, all of the capabilities that enterprise environments have come to depend on. So it's still a significant area of storage devices, both SSDs and hard disk drives. So it's something that still is important today.
And this is always, I still say all the time is, you call it legacy, I call it production. Quite often we get sometimes caught up in the hype of things that are coming and forgetting how broad and widely adopted a lot of these technologies are. They're still going to be in play for a long time. And as fast as technology moves and workloads change, AI workloads being the hottest thing lately, of course, what we're seeing is that more and more innovation in other areas allows these technologies to continue to add value and actually come to the fore. So what we're going to see even on the software side, database technologies, which were very limited before, now are suddenly moving back to the front because of capabilities that are happening with some of the stuff that's going on the protocol side to allow software to kind of latch on to better capabilities and use more of what's there. With that, I guess we'll talk about the real hot topic and the most prevalent, I think, that we see is NVMe. So, Fred, let's talk about where that came from and, again, what's coming up in the NVMe world.
So NVMe is a technology targeting the solid-state drives, SSDs. It's a protocol that's built specifically to achieve the maximum performance that technology offers. So its primary transport technology is the PCI bus and the different speeds that is available in different generations to get as much as performance as possible out of those SSD drives. So in addition, that was expanded into the network world with NVMe OF, where the transport can be any number of different things. We have the ability to use RDMA, the ability to use Fibre Channel as the transport to carry the NVMe protocols. We have several others using TCP/IP that can carry that as well. So the fabric technologies are still a very large part of the NVMe environment. In fact, second only to the PCI area is the Fibre Channel area. That is a very large adoption area for the NVMe protocol. So we have it both in the direct connect technology of PCI as well as the fabric technologies everywhere from TCP through Fibre Channel through RDMA or many other kinds of wires that can carry those protocols.
Now, I guess the next one, when we talk about the distributed workloads and the hyperscalers and what we're seeing with more disaggregated infrastructure, this launched also the need for what came to be CXL. We're seeing new innovation and ideation coming around UltraEthernet. So, Craig, do you want to share, what is CXL at its core and UEC, and what are you seeing that's being done in the SNIA community related to both of those things?
Well, CXL is interesting new technology. It's both a bus and a network potentially. As the CXL matures, it's becoming more and more. It's reaching out more and more to allow for broader configurations. The one thing that really is an interesting promise of CXL is to use memory more efficiently, to be able to have pools of memory. You might have tiers of memory when you have your local host memory, which is your fastest access, and then the idea is you CXL pool, which is maybe a bigger pool, but it'll be a little bit slower access because, of course, latency going out. You always have higher latency when you go out of the machine, but you still have a higher speed memory out there than you might have for other storage or types of technologies. And then UltraEthernet is the new kid in the block. It's taking a lot of the lessons learned over 20, 30 years in networking and applying them to a whole new set of features for dealing with congestion, very, very large deployments, in terms of millions of nodes, data loss protection. And the idea is to deploy this in HPC as well as AI workloads. And, there have been existing technology that can do this. DCB, data center bridging, and Ethernet is one of them. And UEC really takes that to the next step and uses the most recent technologies.
There's definitely a lot of stuff, and we're going to have independent podcasts and some of the conversation. There's information that you can find as well. So I recommend folks that are dabbling with looking ahead, look for a lot more that's going to come up with what SNIA and the UEC folks are doing. So pretty cool there. Now, since we're talking about down to the form factor, and we've got these wild new deployment patterns and operational patterns, we're changing how we're physically deploying. So let's talk about SFF, my BFF. Anthony, what does SFF do for us, and what has SNIA sort of created with the work that you and the team are doing?
Yeah, so Fred and Craig talked earlier about the transport layer. What we're trying to do is basically build the electromechanical interconnect between a host and a device. And so what SFF does, essentially, we create those cables, those connectors, form factors, all of those bits and pieces that are needed so you can physically assemble these devices together to go talk to each other.
And one thing that popped up was EDSFF, because we never have enough acronyms in our world. So tell us more.
Yeah, so EDSFF, which I guess word of warning: never have engineers design a name for a device. So, but EDSFF was built as a ground-up solution to basically solve a problem around existing storage form factors. Like a lot of the form factors, or a lot of the form factors for storage, were built around the hard disk drive. And as we went into the SSD era, I mean, not that our hard disk drives aren't still around, but going into the SSD era, we needed new form factors to be able to cool them, to be able to fit more into a certain form factor or the certain server or device. And so what we did is we created this ground up standard to be able to be able to fit into some of these servers and new server usages. And so we created EDSFF in order to go solve that problem. And it's kind of taken off on its own, because now it's not only being used for SSDs, but we're also using it for like a CXL memory module. It's being looked at from a network form factor as well. So it's kind of taken off into its own usages.
And because of that, what else are you seeing in general in the industry that is making use of this and in the SSF world?
Yeah, so I mentioned the SSDs, CXL memory, and the network devices. Really, some of the other things are what are we doing about AI? Basically, what do you do about some of the processors for that? And so we've been looking at solutions for that. We've been looking at cabling to connect to some of those devices, whether it's copper or optical interconnects. And so our transceivers group has been working on updating specifications to not only hit like the current speeds, but what are we doing in the future for 224, 448 plus, right? So a lot of these higher speeds.
I'm still holding out for ATM at the desktop. I'm old school. I remember working at the financial world, and we actually had ATM cards going to trader desks. So it's been surprising where I guess that's, for me as an outsider looking in, that's what's been fantastic to see the birth of these standards in SNIA, and then the innovation that occurs through the industry partnerships. And then sometimes what's old becomes new again, and we see, because of changes in patterns of applications and infrastructure, none of these standards are there for a reason, because then we have a well-defined method and group of folks that contributed to that collective standard. It's very, very difficult in our world where people can just, pop up a startup, come up with a brand new idea, and then go completely independent and proprietary. And then the risk there is then the ability to innovate is kind of capped. You can do a lot, but ultimately it's whatever the proverb would be, is that we get there faster by going as a group than going alone. So it's been interesting to see. And let's move on. We'll talk about, because I haven't got enough puns left in my world. Should I stay or should I go? STA, Anthony, what is STA and what does that come into play around the SNIA world?
So STA is the SCSI Trade Association, but basically their mission is to promote the understanding and use of serial attached SCSI. And really what they're doing is they're trying to influence the evolution of SCSI standards to meet future industry needs.
Now, what do we do? What are some of the, meetups and things that we do in order to drive some of those conversations? Because folks may not, if they're brand new to SNIA, they may not know kind of what type of stuff. I know we've got plug fests, we've got other things that we do. What are our ways that people actually collaborate on these ideas?
I mean, I think the biggest one is probably the plug fest, right? There's SAS plug fests that occur every so often that people can kind of come into a room and do effectively a does my device work with this? Does my device work with that? And kind of come in and go and flush some of those, maybe flush problems out, maybe flush out some concerns that they've had, and being able to go see that. And then, of course, there's also obviously joining STAY.
And luckily, it's super easy to do. That's one thing I found SNIA is fantastic of being able to reach beyond your current column of people you talk to. It's easy to spread across the practices and pillars. So with that, I mean, looking at NVMe, of course, we mentioned that's obviously a big area of work. So Fred, Craig, what are SNIA's activities that are using NVMe and innovating and building around that?
Well, there's several activities that SNIA has partnered with NVMe. An interesting one is the computational storage area, or having compute near the data. And NVMe has worked on the project at the protocol level to enable the interaction between the operating system, the host, the applications, and the computation that lives in the storage device. And SNIA has been working on application layer APIs so that applications can take advantage of those capabilities in a standard way. So we have at the SNIA layer, the SNIA organization, we build the standards for the layer of the applications, for the device drivers, for all the communication within the host. And then NVMe is working on the protocol to carry that information from the host over to the storage device where the operations can actually occur. So it's a very nice kind of cooperative effort between SNIA and NVMe on how that having the compute near the data, the computational storage, work together between the two organizations. We've also developed within SNIA something called the NVMe-OF drive specification, which is a common connector, a common way to put a bunch of NVMe-OF drives together and have those connected up over Ethernet or something such as that. And that is a common specification that SNIA built, but which operates with NVMe drives in that packaging. So you can imagine a shelf that has a bunch of either straight PCI NVMe drives that has an Ethernet front end to talk to a host, or maybe it's a bunch of Ethernet NVMe-OF drives that are all in that shelf that are all connected then to a host, where SNIA has been the designer of that specification, packaging, and connector, whereas it's the standard NVMe protocol that's used to communicate to that shelf of devices. So we've also,
as I say on the management side now, then that becomes you're not even just at the protocol layer, but the management layer, which is pretty nifty. So I saw Swordfish pop up in the talk track. I'm like, oh, Rochelle's ears will be burning in a great way. What's the connection with Swordfish and NVMe?
Well, Swordfish is the storage part of the Redfish management operations that are for entire platforms. So the Swordfish part is the storage part, and that is developed by the SNIA organization. And so we interact with a number of the protocols. NVMe is of course the latest, but we also include management of SCSI and other storage protocols in that Swordfish management capability. So we also have something called SDP that we're working on within SNIA. That's storage data placement. Everyone probably remembers from the hard drive days when we talked about cylinder, track, and sector, where you could design applications that knew something about the geometry of the hardware, and you could take advantage of that to build a faster access to that storage. Well, with solid state drives, we don't have cylinders, track, and sectors anymore, but we do still have fancy hardware components involved. And having some level of knowledge about that, or being able to provide knowledge to the drive about the data itself, are ways that additional performance can be eked out of those drives. So the SDP program is a way of looking at the zone storage that's provided by both SMR drives as well as the zone devices within SSDs. It can also apply to the individual die level within an SSD through something called, help me, Bill. What's the name of is it FDP? the name within NVMe?
Yeah, it's
Flexible
FTP.
data placement.
Yeah.
Yes, the flexible data placement, where the host can indicate to the device that there are certain sets of data that are related to each other, and so they should be placed close together within the SSD architecture, so that the management operations within the device can get some better performance by knowing that information. So the way to do that is, again, through an application layer API, which is what SNIA is developing in its storage data placement specification, to be able to provide a way to interface to the storage level protocols, which are either the zoned devices or the FDP, the flexible data placement devices. So again, a cooperation between SNIA managing and operating the data and providing information and attributes about the data to the lower level protocols, which could be either SCSI or NVMe.
One of the things that was fun about SDC a couple of years ago, I remember bringing some folks who were, I'd been working with in the industry who were on the software side in, and introducing them to folks at SDC. And it was neat to see where work like stuff that's happening with FDP, there were some people are trying to tackle it on the software side, not realizing there's opportunity where there's work that's being done on the hardware layer. And it's, I guess we look over decades, right? When everything came off at first of Flash, we worried about, what's the life cycle of it. And then the more and more that we drive this innovation on increasing the ability to, we can reduce wear, we can increase, sustainability. And for the folks that were around 2 years ago when sustainability was it was dripping off the tongues of every vendor marketer, we have always been working on sustainability. And at the protocol and at the placement layer, that's where I think is really cool that people don't always see this stuff on the outsides, in the consumer market, but this is the kind of work that allows us to really stretch the life of hardware and have a true impact on sustainability. And since I'm old school and I'm going to go back to my FC world, let's talk, Craig, on what has been done with around FC and what is going on with stuff that makes FC and the definition of some of those specs important in what SNIA is doing.
So SNIA and Fibre Channel have worked together for a long time, going back to some original management profiles that were done. And this is probably 15, 20 years ago. All the way up to today, the work is taking place around security. SNIA and Fibre Channel have been working on a joint security white paper. It's actually an update of a white paper that's been around for a while. And, security protocols change based on best practices. And so currently, they've been working, SNIA and Fibre Channel community have been working together to update the existing white paper and that the knowledge around that with the existing best practices that the security community is using. And
the good thing too is for folks that maybe don't even recognize all the stuff that's going on, we're going to make reference to some of the white papers and other work that's been published. There, if you go to the SNIA site, of course, you can check through the document library. There's lots of information there. We'll include some links in the podcast notes as well. And of course, anybody that wants to reach out, just always hit up the folks at SNIA, and you'll find that there's a lot of stuff that's been done and great reading and research that we can tap into before we think we've got a new idea going forward. And then it goes beyond this because it's not just within SNIA, but the partnerships. And that's why CXL was interesting, because, of course, CXL is fairly far along in some of the work that's been done. The specification has moved up in version numbers quite a bit since I've been watching it and since it's been around. So, Craig, Anthony, if you guys want to sort of pick and choose who wants to talk about what is the relationship with SNIA and CXL and what you see as kind of neat things that are coming ahead for us.
Well, it's still being explored for CXL, but some possible future tie-ins might be into the SDXI work group, which is a SNIA data mover. There might be some interesting things working with CXL and that. And And so XDXI is a standardized data mover that allows you to have a hardware data mover that software, more than just a proprietary driver, knows how to use. And when you're talking about moving data in between pools of memory in CXL, that could be a good fit. And so that's just one of the areas that are possible fits for SNIA and CXL. But it's a new technology, so it's still open as to what exactly all the different applications could be.
So let me jump in there with one other thought on that as well. One of the things we are looking at in SNIA is we're looking at how do you merge three different things? How do you merge CXL, computational storage, and SDXI? And you can take all three of these things and merge them together to provide an environment where you have different types of data movement, you have coherency, and all three protocols working together. And we're looking at that currently within SNIA, where we're looking at taking two of our technical work groups, the computational storage work group and the SDXI work group, and working together on that and how we incorporate CXL with that as well.
Nice. And Anthony, you had something to add as well?
Yeah, and we've had a little bit of collaboration there on terms of the CXL memory side. I mean, I mentioned the CXL memory module before. That was a collaboration between the SFF portion of SNIA and JDEC. JDEC doing the memory side, and then CXL being involved from the protocol transport side, and then us from the physical hardware side. So it was a really good industry collaboration, and a really good example of what we can do when we kind of all put our heads together, kind of go solve a problem.
Exactly. And this is, again, why I've been a longtime fan of SNIA. Well, it's a bloody honor to be able to be the host of the podcast, because I get to hang out with amazing folks like all of you and see as we go to watch this evolution over time. And as you said, even the organization evolves as we see working groups begin to sort of merge and collaborate and cross over. It can't be done in a vacuum, and certainly can't be done in an ivory tower. So it's great to see. I know we've got one more quick thing to hit because we got to wrap, and I wish I could do this all day with you folks, but let's talk about the far future and very early work. What about UEC? Craig, we mentioned it a bit before. What is the state today of the work with the UltraEthernet consortium, and what do you see as the next stages for folks to be able to watch and get involved?
So right now, the UEC and SNIA are working on an alliance agreement, and UEC is in a development phase right now. No specifications have been released. So at this point, I can't talk about specifics within UEC. Coming up in the next 6 months or so, you'll start seeing some more public information on that. But some areas that I think that SNIA and UEC can really work together on. SNIA just started a task force to look at AI applications for SNIA, and UEC, I believe, could be a big part of that, especially in some of the storage areas. But without having everybody sign an NDA, unfortunately, I can't talk more about that at this point.
Well, and again, I think this is why this has been such a fantastic chat. And I know it's been a bit of a speed run through things, but if I would go back to why we did this and why this is such a great discussion to have, we can see the breadth of coverage that's happening within SNIA, the amount of people that are collaborating and being there as we define what's the future, what will UEC look like, what will the collaboration look like, being able to get involved and to spend time with fine folks like yourselves. I tell people just go, jump in. Being a part of SNIA is a beautiful thing. It's not costly at all, and it's also just nothing but positive as far as I've seen. And now that we're doing more and stuff back in person, we saw SDC in Austin, so we're seeing maybe even some more quarterly and more often and more regional events where we can collaborate. It's a great chance for people to get involved and jump in. And again, I want to thank everybody. You've all been great today. Bill, just one last thing. what's, if you could collapse it into a couple of sentences, why is all of this awesome, and what does being an expert on data in the transport world mean to you? Oh, we got you muted there.
Well, thank you. I think the biggest thing is, it's been said over and over, we are collaborating with a large number of organizations that are all related to the transport of data, and we bring them together, we work together with them, and as Anthony mentioned, it's even a matter of kind of being the centerpiece that brings other organizations together to enhance the overall industry in terms of how we transport data. And we will continue moving forward with that as we move into the next generation into UEC.
Amazing. Yeah, and it's been an inspiration to watch. Thank you all for taking the time to share today. Again, for folks that are brand new to us, make sure you do go head on over to the SNIA website, get yourself signed up, join the community, watch. We've got the Experts on Data podcast is both in audio format. It's also on the YouTube channel. So if you're listening, pop on over and you can see these fantastic, beautiful faces directly. And if you want to see them in person, we've got lots of events that are coming up. Head to the SNIA page, check out what's ahead, and watch for more as we talk about all of the different practice areas. Thank you all, folks. My name is Eric Wright. Again, thank you for listening to the SNIA Experts on Data podcast.
Thank you for listening. For additional information on the material presented in this podcast, be sure and check out our educational library at snia.org/library.